Greetings. This is sort of a part 2 video of the one that I did on the receptacle that burned up pretty good, as you can see. I wanted to talk about what you can do in your home, especially older houses, to prevent something like this happening. Now, I have installed a device on the circuit for my workbench, for my plug strips on my workbench and on my computer, because I'm always screwing around down here, and Lord knows I don't want to have any issues. But I'm sure everyone is aware of what a ground fault interrupter is, a GFI, GFCI. And some people may not be aware of the AFCIs, or arc fault interrupters. I have this guy here mounted on in the circuit that feeds my benches, and this is actually a dual purpose. It's an arc fault and a GFI unit all in one. And if some of you may not know, that a ground fault works by sensing the current between the neutral and the hot. And if you have an imbalance, such as you coming to ground, it'll sense that imbalance and trip. It's usually around 5-6 milliamps. That's what we tested them for when I worked at the hospital. And an arc fault will sense if you have an arc. Now, what takes place in anything on a hot connection that's starting to heat up and burn, as in case of this, there'll be some type of arcing in there, and the algorithm in the device and electronics can sense that. It can sense between the neutral and the hot, and it also can sense it between the hot and the ground, and it will trip out, and thus protecting all your wiring and devices, whatever's in there, and your house and your life. If there would have been one in this house, obviously this wouldn't have gotten this far, because it would have tripped. Now, there's two things you can do. There are two ways you can do it. You can buy them as breakers, circuit breakers, such as some of you may see the ground fault circuit breakers in your electrical panels. Or you can buy them as a device that looks like this. It's receptacle, and you can install them in your branch circuits. If you install it on the first receptacle of that circuit, it can protect everything down line. Now, I don't recommend you getting into your electrical panel by yourself. I'll talk about that in a minute. But if you're comfortable working on changing receptacles and you have a good idea of how to do that, there's plenty of information on YouTube about how to change a receptacle if you don't know. You can replace them and give yourself a little protection in areas that's needed. In my case, my workbench, and I don't want anything happening there. And you can put them on other circuits in your house. Now, the code requires that you have this type of protection in your new homes as they are built. They require the arc fault in areas. But you don't want to get into the electrical panel unless you're really experienced. And I'll talk about that in a minute. But there are two ways, as I said, there are two ways you could do it. You can install the receptacle type, or you can have someone else that knows what they're doing install it. Or you could possibly find out what type of circuit breakers you have off the information off the circuit breaker in your panel. And you could buy a few at a time, because here's an example of one. They're kind of pricey. These ones are around $65 each. So if you little by little bought a number of them, and you could have an electrician come and install them for you in an older home to offer you some better protection. These are around $30 a piece, so it's a little cheaper to use those. Shut the power off and install them. In the last video I mentioned on making sure that you have the power off. You could trace it with, you could get one of these tracers, these to tell you, these non-contact voltmeters, especially if they don't have a voltmeter. And this voltage tester will tell you whether you have the circuit breaker off, or they also sell the circuit tracers. Here's one here. This is a cheaper one. It's not as good as what I used when I worked in the industry. Now this one has dual purpose. It's kind of nice. It will also, you plug the transmitter in and it will test for proper polarity. The lights will light up, and there's an indicator chart there that tells you what it might be. And it will also test ground faults with the button here. You can test your ground faults on a circuit. Most of the ground fault, all the ground fault breakers, they have the test button on them. And there's a test button on the units if you happen to have them mounted in your bathroom, your kitchen, or wherever. But you can also test it with something like this. And this guy here, you just plug this in and you can turn it on and just go back to your panel, and you'll hear that beeping sound, and you can lower the sensitivity to isolate the particular circuit that you want and shut it off. So be safe. That's the key. And I also mentioned something in my last video that took some flack, but let me explain my view when I mentioned that. So is the receptacle upside down? Is it right side upside down? There's no code right now, but I suspect in the future they're going to do something for conformity. I'll tell you why. But way back in 1970, when I first mounted my first receptacle, was in high school. I went to a vocational school, and they actually had a grant. And in those 3 years, we built a house out back. All the trade classes, the carpentry, masonry, everybody, we all worked on that house. I worked in it some, and I think later on they tore it down some years later after I had graduated. But we were told ground pin up. Now nobody ever explained to us why, and there was never no code to say that. And when I worked construction in Florida, make sure the ground prong was up, they told us. And when I worked at the hospital for over 40 years, we naturally installed them that way, but there's a reason for that in a hospital. That's why I said maybe they'll do something for conformity. It doesn't matter in your home. And one place that might matter in your home is, you have a lot of power packs to supply devices, and a lot of them have, if you mount the receptacle ground prong up, if you'll notice, you plug it in and the cabling comes out of the top. The thing doesn't sit level right when it's plugged in. So there may be an instance in your house where you'd want to have them this way to accommodate those units. Now, interesting, a couple years back, we've bought some recliners and the couch that have the power the head and the foot up, and those actually were oriented where they would plug in and hang properly with ground prong up. So I don't know. It's just a political thing. Let's not make a big issue about this. It's like saying, who do you like, President Biden or Trump? Let's not get an argument over just a statement of somebody's view. But let me tell you why in the hospitals. In the hospitals, if you talk to any electricians and even look it up on the web, I say, why are receptacles ground prong up in hospitals? Because there are some critical areas, and if anything drops down on those prongs, can cause an issue. And my thing that I found that I dealt with many, many times is in the patient rooms, they use metal cover plates. Why metal cover plates? Well, they're, offered a little bit more secure. I don't know, but they put metal cover plates in. So if you are ground prong down, and I'm telling you, constant use in a hospital room, no matter how much checking you do, because we had to periodically check and test every receptacle and make sure they weren't damaged in that hospital. And actually, we broke that up by floors, and I had the guys take different floors, and we would have to document all that. But what happens is, through all this use, these things do come loose. The screws on the ears come loose, and the receptacles slide around. The screws on a metal cover plates would come loose and actually fall out. And I've had to change a number of these because what happens is, if staff is plugging something in and out, you have the ground prong down, guess what? They don't notice that screw fell out, and that thing will fall right down, right across the hot and the neutral, and bam, you've had some sparks. I've had that happen even with the other orientation, where the ground prong is up, and I've had them, they fall down, and most of the time they would hang on that ground prong, and staff would report it, and we would come and take care of it. But there have been a few times where, it jiggled around and it hit on the hot, and there were little sparks before the breaker tripped, and everybody gets all excited. Then you're writing up an incident report. So this saved a lot of grief. And what I did with the metal plates is, I actually, if I found one loose, I replaced the screw. But you can buy short 632 screws that have that plastic Loctite already on the threads. So I used those, and I replaced, they were stainless steel screws you could buy, and I replaced them on the cover plates, and it held them in a little more securely so they wouldn't fall off. So that's my shtick of why I look at something and say, oh, that's backwards, because I just been doing it all those years. When you're taught to do something a certain way, and then you find a reason, and you're doing it for most of your life, you look at it, and so that's the end of that. Let's not discuss that anymore. But we had to test the receptacles, and and we tested them for and the just for any damage, loose screws, and something you might want to consider in your home, especially an old home, is we tested the ground prong tension. I've seen metal plugs that practically fall out of old receptacles in houses. Not good, not a good connection, and that will cause overheating. But this little device here, you can see, you plug it in, and I can't remember what the tension limits are. It's been a while since I've of course done that, but you can test the ounce pull on each of the prongs, and then you have one for the ground prong, so that if the tension is weak, we replace the outlet. That's what we did at the hospital. Now, getting back to installing those breakers in your panels, you really don't want to, because of the arc flash capability. If you don't know what that is, look up arc flash on YouTube. There's plenty of videos, and it's really dangerous. Even in a 220 panel, you can get a flash, and it will destroy your clothing and burn you. Anytime I worked in anything hot, I used took proper precautions. Now, the contractors that came in, they weren't allowed to work on anything hot. They had to turn everything off. But there were many circumstances where I had to go in and work on hot, because you couldn't. You're in a hospital environment. You couldn't shut a panel down. You couldn't shut things down. You had to troubleshoot. So rather than having the protective coveralls, I had uniforms, and the Endurasoft uniforms, and the shirt and pants. And of course, you had to wear a cotton t-shirt, cotton underwear, cotton socks, and you had proper footwear on. Here's a picture one of the guys took years ago with me and my hands an electrical panel. I had the whole 9 yards on, the gloves and the you know face protection and hard hat all in one. But it's good to be safe because if you have a flash, you're going to get burnt. You're going to get hurt, and it can happen at home in your 220-volt panel. You have no idea what the guy did that was in there before you, and it is very safe to do that if you have proper protection and know what you're doing. And all you electricians that took arc flash classes, you know what I'm talking about. And so it's better to have somebody else get into your panel, and don't do it yourself. And if you're comfortable putting one of these uh, AFCI receptacles in on a circuit where you may think it may be needed, a little extra protection in an older house, go for it. Replace as many as you want in the circuit. Find the first one that feeds the rest of the circuit and put it in and wire it up, and it'll protect the rest of the circuit. But I never had to work on any high voltage. My job description was up to 600 volts, except there was one circumstance where I did. Generally contractors took care of the 4160. That's the 4,160 volt feed, or sometimes they call it 5,000 volt coming into the building. We had rooftop cutouts. There were substations on the roof. And there were times in the middle of the night I had to go out in emergency. Sometimes those fuses get weak up there. So I had to don the whole suit, as you can see, that's what and that they look like, the 40 calorie suit. And they're heavy, they're hot in the summertime, and grab the hot stick and go up and change the fuse. That's the only time I had to deal with in an emergency situation. So that was a plus for me. But I've known a couple guys personally that actually got killed on high voltage. It was a sad thing, and it was mistakes. Both circumstances was there were a mistake made, and that's all it takes. That's all it takes. So you have to be careful. Don't get in your electrical panels, please. Um, so that's that's about all I wanted to talk about today. So until next time, God bless and have a good Christmas.